guys, today we're going to talk about cube roots, which we've spoken about before. Just like square roots undo the squaring process, cube roots undo the process of cubing a number. So this is the technical definition. If x cubed equals a, then the cube root of a is a solution to this equation. Or the cube root of a is any number that, when cubed, gives a. So in other words, when you find the cube root, you're looking for the number that you multiply 3 times by itself to get the answer. So these are some basic ones that are good to know and have memorized. So we're going to talk about these quickly and justify it using a multiplication statement. So the cube root of 8, we're looking for the number that we multiply by itself 3 times and gives us 8. So that's going to be 2. And here's my justification. 2 times 2 times 2 is equal to 2 cubed, which is 8, right? 2 times 2 is 4, 4 times 2 is 8, okay? The cube root of 1, possibly the easiest one of all, is 1, and that, of course, is because 1 times 1 times 1, which is also 1 cubed, is equal to 1. The cube root of 27, also good to know, it's going to be 3, okay? And that's 3 times 3 times 3, which is 9, times 3, which is 27, or 3 cubed is 27. Now, remember we talked yesterday about how we cannot have any negatives under the radical sign when you're squaring something? That's because it's impossible to have a negative number multiplied by itself once to give you something positive. When we get into cube roots, however, it is possible because you're multiplying the number 3 times by itself. So we know an uneven amount of negatives, when multiplied together, will give us a negative. So they're actually possible here. So the cube root of 0, of course, is going to be 0. 0 times 0 times 0, or 0 cubed, is equal to 0. So let's take a look at these negatives. The cubed root of -1 is going to be -1. And that's because -1 times -1 times -1. Think quickly. -1 times -1 is +1 times a -1 gives me my -1 back. So remember, when we first learned about this stuff in the beginning of 7th grade, we looked at a pattern. We saw even numbers, we always got the positive. Odd numbers, we always got the negative. So this is an example of that. When you're multiplying an odd number of negatives together, you get the negative answer. And so that's why you can have a negative cube root. Okay, so anyway, -1 times -1 times -1, that's the same as -1 cubed, which is equal to -1. So following that pattern, what do you think this will be? The cube root of 8 was 2, so the cube root of -8 must be -2, right? -2 times -2 times -2, that's +4 times -2, which gives you your -8. So -2 cubed is indeed -8. Okay? So now, one of the most striking differences between square roots and cube roots is that you can find the cube root of negative real numbers. However, for square roots, like I've said a million times now, you have to wait until you learn about non-real numbers or imaginary numbers in Algebra 2. So we're going to quickly use our calculators and a guess and check scheme to find these cube roots and then justify using a multiplication statement. So they want you to kind of use guess and check, but I'm going to just show you how to do the cube root. There's 2 different ways. The best way to do this is to go into math, and you go down to 4 here. That's your cube root. So you do 4, there's your cube root, and put in your number, 343, and push enter, and you'll get that it's 7, okay? And the multiplication statement, 7 times 7 times 7. Now, it doesn't seem like it would be that big of a number, but it is. If you put 7 cubed, you can do caret cubed. You'll see that it is 343. Okay? So that's 7 cubed, which is 343. Now we're going to find the cube root of -2,744. So again, you can go to math and go to the cube root, which is 4. Okay, and then negative 2,744. Negative 14. Okay. So my multiplication statement is negative 14 times negative 14 times negative 14 is negative 14 cubed, which is negative 2,744. Okay. And finally, excuse me, we're going to do the cube root of, oops, I pushed enter. I'm going to do the cubed root of, I can't focus, 12,167. And I get 23. And again, 23 times 23 times 23 is 23 cubed, which is 12,167. Okay, so most calculators have a cube root option, although it may be harder to find than the square root button, so I just showed you. You guys can see where it is. And now these ones we're going to find them to the nearest tenth, okay? So they're not all perfect cubes. So we're going to do the same thing, math, 4, and the cube root of 100. 4.64, so to the nearest tenth is 4.6. Okay, now we're going to do the cube root of negative 364. Negative 364. And you get negative 7.14, so that's negative 7.1. And finally, the cube root of 982. So 4, 982, 9.9. And that's that. Okay, nothing too crazy. All right, so now let's discuss, of course, the cube root function. Time to make things more complicated. So the cube root operation gives rise to the cube root function. Like the square root function, its basic graph is relatively easy to construct. So let's consider the basic cubic function, the cubed root of x, and we're going to fill out the table. We don't need the calculator for this, we just found all these values before. The cube root of negative 8 was negative 2. Cube root of negative 1 was negative 1. 0 is 0, 1 is 1, and 8 is 2. Okay, so we're going to plot the graph based on these values that we have. So, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. I'm just skipping by 2's here. Okay. Okay. Okay, so negative 8, negative 2. Here's negative 8 and negative 2. Negative 1 and negative 1. 0, 0. 1, 1. And 8, 2. So when you connect these, you do not want to make straight lines. You want to let it scoop on through, because what a cubic function looks like is almost like a little sneaky type thing. Whee! Like this. And of course mine's not perfect, but this is what it looks like. So what we're going to do instead is we're going to take our calculator and take a peek and make sure that that is accurate. So to enter this in, you go back into math and get your cube. Remember, you can get there by using the arrows, but you can also just push number 4. Enter, and then inside here we're putting X. Get out of there, push graph. And I must have had mine on a silly window, so I'm going to do zoom when it stops thinking. Zoom, and I'll do standard 6. And let's take a peek. Whee! Now I'm going to zoom in a little bit closer so you can see that that's kind of curvy. Let me see what zoom fit does. It's probably going to be the same. No, it's a little bit better. Yeah, so as you can see, a way closer up version goes whoop, like that right through. Just like, sort of like mine. Not really exact, but sort of. Okay? So, that's the graph. And of course, naturally, one of the things that we did a lot of in algebra was shifting our graphs and looking at how the resulting equation changes. So to finish off, what we're going to look at is this function, we're going to see how it's been shifted. And we'll see if the pattern holds. What we've noticed in the previous functions that we've looked at, if there was a number inside the square root or parentheses, it did the opposite of that horizontally. And then the number outside did exactly what it said. So for example, our prediction would be that this would be left twice, and then this would be down 4. So we're going to see if the pattern holds. Okay, so we're going to use the calculator to create a table of values that can be plotted. Okay, so basically I'm going to put this in here. So I'm just going to go back in here and I'm going to change it slightly. So it was x plus 2, and then to get out of the square root, I push the arrow, okay? Oh my gosh, and then minus 4. So I'm not going to look at the graph yet. I'm going to look at the table so I can get some values. That would be easy enough. So let's see, where could we start? Let's start with negative 10 and 6. And now let's find the next whole number value. Oh, right here, negative 3 and 5. And then negative 2 and 4, that's nice. Negative 1 and 3. And let's find the next one. 6 and negative 2. Right, and that should be good. So let's make a graph, take a peek, and see what's happened. Alright, so I'm going to do the same thing I did before, just so I don't have to label as much. Okay. 2, 4, 6, 8, 10. 2, 4, 6, negative 2, negative 4, and negative 6. Okie dokie. Negative 10 and 6. So that's negative 10 and 6. That's all the way at the corner here. Negative 10, negative 6. Bethany. Okay. Negative 6. These weren't negatives before. I'm terribly sorry. I don't know what happened. Negative 10, negative 6. And negative 3, negative 5. Negative 3, negative 5's here. Negative 2, negative 4. Negative 1, negative 3. And then 6 and negative 2. So what we can see is our graph did move over to the left and then down, right? So let's see if it really moved left 2 like we predicted and down 4. 1, 2, 1, 2, 3, 4. Voila. So it did. And so it does follow the shifting pattern that we've discussed in the past. Okay? So shifted left 2 and down 4 units. Okay? So that the shifting pattern works for parabolas, it works for square root functions, and it works for absolute value functions, and now we know it works for cube root functions also. Okay? And that's it for today's lesson. I think for your homework, I didn't give you any of those graphing questions. I think I only gave you practicing cube roots, so don't worry about that. Okay? All right, have fun. This is the last lesson in this unit. Woohoo!